The objective of this video is to give an introduction to significant figures. So what we are basically going to do is trying to understand what these significant figures are. And then we are going to go over the significant figure rules, which helps us to count the number of significant figures in a given number. And then we are going to look into why we even have these significant figure rules. The significant figures, also called as significant digits. Now, when you see the word significant digit, you can understand that it is all about numbers. Now, these numbers can be two basic different types. One type is called as the exact number. As the word says it, exact. You exactly know how much there is. There is no uncertainty, no guessing. You know exactly how much there is. So what type of things fall under exact numbers? They can be definitions. So definitions are exact numbers, like the dozen. A dozen is a definition that defines 12 objects. So if it says a dozen of eggs or a dozen of anything, you know that you have exactly 12 objects. And things like the definition mole, something you come across at a later point. The mole contains exactly this many things. Those things can be atoms, molecules, or anything. What else fall under exact numbers is the conversion factors. So the conversion factors, like the conversion factors in metric system or metric to English system, those conversion factors are known as exact numbers. The things you get from counting objects, those are also called as exact numbers, like how many apples you have here. 1, 2, 3, 4, 5. You have 5 apples and you know exactly you have 5 apples. What else? Simple fractions. So the simple fractions are also considered as exact numbers. Fractions like this or even pi. Now fraction is not as same as decimals. Now if you look into this half, the half given like this as a fraction is exact. But if you write 0.5, this is not exact. So fractions and decimals are different things. So keep an understanding about what is exact numbers, and the other type of numbers are what we call as inexact numbers. As the name says it, there is some sort of a uncertainty. There is a guessing and some ambiguity about the number we know. So what falls under inexact numbers? Those are measurement. Every time we make a measurement, we end up with some sort of an uncertainty. So all measurements are going to be called as inexact numbers because they carry some level of uncertainty. For example, if you have this object and if you are trying to measure the length of this object, and if you are using this first ruler where you can see you don't have any millimeter markings. Now everyone can read 3 centimeters precisely. Now this object is longer than 3 centimeters, it is shorter than 4 centimeters. So everyone can read 3. So this 3 we read precisely. But this second digit, what can you say about it? You can have a mental partition in this ruler and you can call this as 3.5. Now you can guess where this mark is. So you can guess it is around 3.7. Another person can say it is it is not 3.7, it can be 3.8. So it depends on the person. So one person can say it is 3.7, another person can say it is 3.8. So you can see the last digit hold some sort of an uncertainty. Let's go to the next ruler that we are going to use. The same object. Now in this ruler you can see millimeter increments, and you can clearly read all the way up to 3.567. Now everyone can read the first two digits with precision. Now these two digits are precise. But what about number 4? It is an estimate. So this last digit is an estimate. One person can say it is 3.74, another person can say it is 3.75. So there is some sort of an uncertainty every time we make a measurement. So what exactly is significant figures or the significant digits? That is all the digits known with certainty or the precise ones plus one estimate. So what is that estimate? It is the last digit we estimated. So this one estimate is the final digit we estimated, like in the previous example. So in this first ruler example, this is what you know with precision. Number 3, you know precisely. And this is the estimated number. So this reading, this measurement has two significant figures. Then coming to ruler B, according to this measurement, 3 and 7 are known precisely. So those are the certain digits, and the estimated digit is number 4. So significant figures included all the certain ones and the estimate. So this measurement has 3 significant figures. Now the guidelines in determining significant figures. We always say that all non-zero digits, they are all significant. They're always significant. For example, in this number, you don't see any zeros. So count how many numbers you have. 1, 2, 3, 4. You have 4 significant figures. In this number, you don't see any zeros. Count how many numbers you have. 1, 2, 3, 4, 5, 6, 7, 8. 8 significant figures. The complication is related to zeros, but we can further simplify it. There are different types of zeros. Now let's look into this number. One type of zeros are called as leading zeros. They are the zeros in front of the first non-zero digit. The first non-zero digit you find here is number 5. So these are the numbers in front of the first non-zero digit, and they are never significant. Another type of zeros you find are what we call as captive or confined zeros. They are the ones that is trapped in between two non-zero digits. They are always significant. And the third type of zeros are what we call as the trailing zeros. The trailing zeros are the ones you see after the last non-zero digit. Now, are they significant or not? It is situational. It depends on whether you are going to see the decimal point or whether you don't see the decimal point. If you see the decimal point in this number, those trailing zeros will always be significant. And if you don't see a decimal point in this given number, those trailing zeros will never be significant. Now, why we have these kind of two different rules? So let's look into this trailing zeros first. So let's say if you want to buy a large pepperoni pizza, you might think the price is going to be around $10. So let's say $10. But if you go into the store and check the menu out, you will see that price is going to be like this, $11.00. Now, if you go into this restaurant and give a $10 bill, will you get the pizza? No. Why? This is not exactly what they wanted. So what we get without a decimal point is more like an average. This is an average. So when you see a number without a decimal place, a decimal point, that number reflects an average number. But if you see a decimal point, that means it is precise. So you have to exactly give the exact amount. If you give $10.50, you still cannot get that pizza. If you give $11.01, they will give back that additional cent back. So they are very precise. So these zeros, when you have a decimal point, these zeros have a meaning. And when you don't see the decimal point, the zeros doesn't mean much because it is talking about an average. And then let's go into the captive zeros. Let's look at numbers like this. I will take this number for an example, $5004, and if you get rid of two middle zeros, you will end up with $54. Now you can see there is a huge difference in the quantity. If you remove the captive zeros, that will make a huge change in the magnitude or the size. You can see that $54 is way smaller than $5004. So the captive zeros always have a meaning. Because it has a meaning, it is always significant. Now let's look into leading zeros, why they are never significant. Imagine you have a capsule, a medicinal capsule, which is 1 gram. Now, if this is 1 gram, you can convert these grams into kilograms. So if you convert a gram into kilogram, you can represent this same capsule, the mass, as 0.01 kilograms. Remember that 1 kilogram is 1000 grams. So whether you're going to represent this capsule in grams or kilograms, it's still the same mass. We only change the unit. In changing these units, we had to add some zeros. But did it affected the real mass of the object? No. And that is why we call as these leading zeros has no meaning. They are only called as the placeholder zeros. So these leading zeros are also called as placeholder zeros because they only hold the position of the first significant figure, and they has no meaning, and that is why we don't consider them as significant. All right. The exact numbers. The exact numbers, they actually have an infinite number of significant figures. Why? We know them exactly. The quantity is exactly known. For example, how many apples? 1, 2, 3, 4, 5, 6, 7, 8. You have 8 apples. Now, when we are working with numbers, you have to pay attention to what you are reading and what you are seeing. Now, in this example, did you count or measure? You counted. So counting leads to exact numbers. And if you have an exact number, it is going to have an infinite number of significant figures. What else? Fractions. Any fraction. As long as you see it as a fraction, it is going to be an exact number, but decimal is very different. And the definitions. Definitions are also going to be exact numbers. So if you see these kind of things in any given problem, first read very carefully. So first, what you need to do is read. Read carefully, look at the units. Are you counting or are you measuring? If you are measuring, you will always see a different type of unit. And then think, the number you have, is it an exact number or an inexact number? If it is an inexact numbers, those previously mentioned rules are going to apply. Alright, that's it.